vSphere 8 introduces several changes and new capabilities which alter past best practice recommendations for business-critical applications. In the interest of time, we're focused on just one small but significant change: CPU presentation. We've gone from the leave cores per socket at 1 recommendation in pre-vSphere 6.5 to the use the host physical NUMA topology as a guidepost in 6.5 and 7.0. These recommendations are no longer applicable in vSphere 8. In 8.0, the new recommendation is to just let the ESXi host take care of itself. And today we're going to see what happens when you do that. First, the new CPU presentation algorithm requires the VM to be at virtual hardware version 20 or newer, which you can see we've already done. Existing VMs will have to be upgraded to benefit from this feature, even when they are hosted on vSphere 8. The VM settings configuration menu has changed a little bit in virtual hardware 20. Let's take a look at the difference. There's a new subsection called CPU topology in the VM options. As usual, a VM does not get vNUMA awareness unless it has more than 8 vCPUs allocated. Within this new settings menu, we can specify cores per socket and NUMA nodes. Notice that we are not selecting to enable CPU hot add, but know that there is another advanced setting in vSphere 8 which allows activating this without removing NUMA configuration. So let's add more resources to the VM. In this demo, we will let ESXi do the presentation for us using its best judgment. So we have a VM with 16 vCPUs on 2 sockets on a 14 cores per socket host with hyperthreading enabled. While this gives us a total of 56 logical CPUs, it is important to keep the number 14 in mind as we proceed through the demo. The ESXi host socket has only 14 physical cores, so any VM with more cores than that is considered wide. Now let's power it on and see what topology ESXi has presented to the VM. While that's coming up, let's quickly see what happens when we upgrade the virtual hardware compatibility version for an existing virtual machine. VM hardware version 20 is available only on vSphere 8 and later. The VM is now at virtual hardware version 20. Let's see what changed. Voila! You can see that the CPU configuration menu has moved. Now let's log into our original VM and see what the guest operating system, Windows, sees. The Performance tab of the Task Manager gives us a good place to start. Here we see that ESXi has presented 2 sockets to Windows and has split the 16 logical processors into 2 NUMA nodes. One of the most important things about NUMA nodes for business-critical applications is CPU memory adjacency. Let's check that out using the Windows Performance Monitor perfmon. Here we see that 2 NUMA nodes that Windows sees, node 0 and node 1. Each node has exactly half of the total allocated memory local to it. When analyzing NUMA topology in Windows, coreinfo.exe is a very useful command line tool to be familiar with. Let's see what it reports. Here we can see our 16 vCPUs split into 2 logical processors to socket map and 2 logical processors to NUMA node map. perfmon can also be invoked from the command line. Let's take a quick look at what it reports here. We can also see an evenly split memory to NUMA node distribution. We have a balanced vNUMA topology for our business critical application workload, automatically presented by ESXi, all without having to do any manual configuration or advanced setting manipulations. This is a major change in ESXi 8.0 and a great way for our customers to easily achieve best performance. The rest of the demo is intended to show what happens or changes if we increase the allocation of vCPUs. As you will see, the answer is nothing. It just works. For instance, let's set the vCPU count to 32, remembering that the physical host has 14 cores per socket. Notice we are using the assigned at power on option in the CPU topology settings. Now we will power on the same VM again to show the presentation view from Windows. Here in the Task Manager, you can see 32 vCPUs across 2 sockets. Now let's check out the NUMA configuration. Again, using perfmon to validate. As you can see, the NUMA configuration is upheld. Running the same test via the command line also confirms this. In conclusion, vSphere 8 no longer requires customers to overthink CPU presentation, vNUMA topology, memory locality, and similar settings. Of course, customers can still manually set their own preferences, and while we don't have enough time to demonstrate this, we can tell you again that it just works. As we already know from the previous demo, with vSphere 8.0, CPU presentation best practices have changed from the leave cores per socket at 1 recommendation in pre-vSphere 6.5 to use the host physical NUMA topology as the guidepost in 6.5 and 7.0. These recommendations are no longer applicable in vSphere 8.0. In vSphere 8, the new recommendation is to let the ESXi host take care of itself unless your customer has a need for vNUMA to be presented in a specific way. In this demo, we will dive into specific use cases for these vNUMA settings. In this environment, our ESXi server has 4 sockets, 24 cores per socket with hyperthreading, and each socket has 384 gigabytes of RAM. Again, we see the VM has been upgraded or deployed on virtual hardware version 20. Our VM has been provisioned with 36 vCPUs and 320 gigabytes of RAM. So ideally, it can either fit into 1 physical socket and 1 NUMA node using 36 logical threads of the 48 logical threads on the socket, or it can span across multiple sockets and multiple NUMA nodes. For the first part of this demo, we let ESXi 8 do the presentation for us, using its best judgment, with no advanced parameters and no user-defined NUMA settings. First, let's validate the CPU settings as seen by the Linux guest using the ls cpu command. Then, running the NUMA CTL command on Linux will show 1 NUMA node and 36 CPUs. So based on the advanced placement capabilities in vSphere 8, the VM has all 36 vCPUs aligned to a single NUMA node. Prior versions of vSphere require an advanced parameter setting, numa.vcpu.preferHT, in order to take advantage of hyperthreading. What happens if we decide to go back to pre-6.5 days and set the advanced parameter numa.vcpu.followCores/socket equal to 1? ESXi reverts to the old behavior of virtual NUMA node sizing being tied to CPUID.cores/socket. Not assigning cores/socket to the VM will take the default action. Here you can see we've set the advanced parameter numa.vcpu.followCores/socket equal to 1 to force this behavior. Running the NUMA CTL command again on Linux will show 1 NUMA node and 36 CPUs. As you can see, ESXi decided to place the 36 vCPUs on NUMA node 0 using 36 logical threads with numa.vcpu.followCores/socket set to 1 and the default cores/socket equal to 1. Lastly, we're going to show what happens if we decide to go with the new vSphere 8 behavior, but we have a need to modify that behavior to fit a specific use case. We know from the first part of this demo that ESXi decided to place 36 vCPUs on NUMA node 0 using 36 logical threads, reducing any latency caused by crossing NUMA nodes. However, our workload is memory bandwidth hungry, and it will perform better by using a wide VM configuration across multiple NUMA nodes. To achieve this, we need to specify no advanced parameter for numa.vcpu.followCores/socket, also cores/socket equal to 18, and 2 NUMA nodes. As we can see, we can also assign NUMA nodes to specific SCSI controllers and Ethernet adapters. One last time we run the NUMA CTL command in the Linux VM. This time we see 2 NUMA nodes, with each NUMA node having 18 CPUs. So as we saw in ESXi 8, the default behavior is to present the best NUMA topology for the VM based on the vCPUs assigned. For certain workloads that will benefit from the wide VM configuration, one simply sets the cores/socket manually to assign NUMA nodes in the GUI without any advanced parameters. In conclusion, in vSphere 8.0, customers will no longer have to overthink CPU presentation, vNUMA topology, memory locality, and similar questions like they used to do before this version. Of course, customers can still manually set their own preferences as needed.